All right, so these are very lengthy problems. When you're working with phase changes, the very first thing you need to do is draw yourself a graph. Okay, so I'm going to start by graphing. All right, the normal phase change graph looks like this. All right, now let's put some points on it as to what we've got. We know that we are at -5, so I'm going to put -5 down here because we're a solid. Remember that since we're dealing with water, because notice that this is ice melts at 0 degrees Celsius. It also vaporizes right there at 100 or boils. And then our last mark is if we want to see how much it takes to completely vaporize at 120. So these are the points on the graph that we need to do. So you have to do this in stages. So our first stage, and this is going to take up a lot of paper, okay, is right here. Now, anytime I have a slant, I can use the formula Q equals MC delta T, okay? So I can use that for this first part of it. So I'm going to say my Q, I've got my mass of 50 times the and the specific heat of ice. So the specific heat of ice is 2.05. So 2.05, and then I've gone up 5 degrees. All right, so that gives me a total amount of energy of 512.5 joules. Okay. Now, at this point, I'm going to use a different color. At this point, there's no temperature change. So you've got to use a totally different equation. You're going to use Q equals MHF. HF is the heat of fusion. So that's the amount of energy it takes to melt or freeze something. The HF value is 334. So now substitute in. So Q equals 50 times 334, which is going to give me 16,700 joules. All right, let's look at my next one. Notice it's a slant again, so that means I can use this because I'm going to get a temperature change. So my Q, notice your mass stays the same, okay? Notice that now I'm at water. Y'all should remember the specific heat of water is 4.18. And I've gone up from 0 to 100, so 100 degrees. So when I multiply that, I should get 20,900 joules. All right. Let's look at the next one. That's another portion that has no temperature change. So I've got a third equation that I can use. Q equals MHV, where HV equals 2,260 joules. So sub in your mass of 50 times your HV, which is 2,260, which is going to give you 113,000 joules of energy. All right, we still have one more step. Okay, this is a lot. So now I'm at this portion of my graph. So Q equals, I can use this again because I've got a temperature change. My mass of 50. The specific heat of steam is 2.02. So times 2.02. And I went up 20 degrees. So that is going to be 2020. So why can't I just put in a temperature change of -5 to 120? Because you've got all these areas here where energy is still being consumed in order to go into the next phase. There's just not a temperature change. So you've got to have a value, and that's what these are. Now, the last thing that you have to do is simply add up all of these values. So you add up the 5 numbers, and you should get 153,133 joules. That is a lot of energy to go from 50 grams of ice, 5 degrees Celsius at 100 up to 120 degrees Celsius. But notice that you had to do 5 different equations in order to do that. So here's what you need to remember. If I'm on a slant, I'm going to use this one. So there's 3 times that I'm using that one. If I'm at the solid or the melting or freezing, I've got to use this equation. If I'm here where I'm vaporizing and condensing, I use this one. Now, one important thing is you're not always going to use all 5 stages. I might say that you're starting with water and it goes to steam. So this is why drawing the graph out is so important.